Welcome to the session. Thanks for taking time. Before we get started, I wanted to see by a show of hands, how many people here are doing machine learning training and deep learning training? It's the majority of them. That's awesome. And then how many of you have used Amazon SageMaker for training? All right, quite a few of. That's good. So my name is Sadadal Bhattacharjee, and I am one of the principal product managers in Amazon AI team. I work with customers just like yourselves to understand the problems that they are facing, what issues that they are trying to solve, and how to use machine learning and deep learning in their environment. And I try to bring services which helps them. Today I'm going to talk about Amazon SageMaker, and also specifically about a feature that we launched as of this week called Amazon SageMaker Debugger. I'll be joined on stage by one of our valued customers, Jayant Thomas Jetty. He is from Change Healthcare, and he has been a preview customer, so he's going to tell the story of his experience using Amazon SageMaker Debugger.
Yeah, absolutely.
Right.
Thanks for
sure.
allowing us to
So,
Thank you.
Thank you. So here's how we are going to organize the session today. So I'll just do a quick recap of Amazon SageMaker itself, because many of you may not be familiar what it is. And then I'm going to talk about why machine learning training specifically is so challenging, especially finding issues related to training, what kind of issues people are facing, what are they doing today in order to find out how to get more insight into machine learning model training. Then I'm going to talk about how Amazon SageMaker Debugger works, specifically go a little bit deeper into the insights of it to explain how different pieces work together. And then I will give you some examples of some sample notebooks. Because of the setup here, the live demo was challenging, so I had to take some screenshots and show it to you guys. But things are live, and you can more than welcome to try out the notebooks once the session is over. Then I'll hand it over to Jetty. He is going to walk through his experience of how he has used as a preview customer, and then we'll take Q&A. The only thing is the Q&A will be off stage because of the logistics is a little bit harder to hear. So we'll be here available and in the back after the session to take your Q&A. Sounds good? All right, so let's get started. Just as a reminder, what is our mission? So at Amazon AI, our mission is to use all the expertise that we have within Amazon of experimenting with different machine learning models, training them, try to take that into the hands of enterprise developers and customers and researchers. So it's more or less taking things which are in the area of experimentation, where people are trying to figure things out. How do we distill out the best practices and make sure that we don't have you guys do the undifferentiated work of dealing with infrastructure, dealing with software configuration, or dealing with known issues that are already found and solved, go and have to rediscover that and waste time. Instead, if you have more time to focus on your problem, then that's a win-win situation. And that's exactly what we are trying to do here. So we are trying to bring machine learning into the hands of every enterprise developer. That's our Uber mission. And with that mission, a few years back, we launched Amazon SageMaker as a platform. What is Amazon SageMaker? Amazon SageMaker is a fully managed service. And if you look at a fully managed service, you have to look at how machine learning is done in the industry today. You have different stages. You have the whole process of collecting data, annotating the data, you're building your models, you're going through multiple iterative process of training them, and finally you deploy them. So this is what we call as build, train, deploy. And Amazon SageMaker covers end-to-end and provides you with different services to do that. As you can see here, we have a robust set of services already in place, but with the announcement this week, we are now trying to go the next level. We are trying to figure out how do we close the gaps that our customers have been telling us in terms of how do I get more insight into my training process. So that's where the debugger comes in, and we'll double click on that today. There are other parts that we also heard our customers tell us, like how do I have a quick start notebook? How do I share? How do I collaborate with different fellow developers in my group? How do I isolate? If I am doing some work and then I want to hand it over to one of my other developers, how can I do a seamless transition? So to respond to that, we came up with Quick Start Notebook. Please feel free to try those out. The other thing which we heard a lot from customers is that even though in traditional language development like C++, Java, and so on, there are well-known IDEs that people are using, whereas in machine learning, it's challenging. There are bits and pieces, there are some open source, but there is no holistic IDE which lets you go from taking an experimentation, running multiple trials, looking at how the different metrics that are emitted, look at different graphs, chart them. All of that end-to-end flow is just not there. So what ends up happening is machine learning engineers and developers just like yourselves, you have to spend a lot of time to do that. And once you do that, you feel like, hey, you spend so much of amount of time and effort just to set things up, just to get things working, where now you feel that you could have easily used that time to focus more on maybe looking at deeper into your machine learning neural networks model. So to address that, we announced this week a product called SageMaker Studio. And the Studio, what it does is it gives you a holistic end-to-end view. It's a visual view where you can create your own experiment. You can create multiple training trials within it. And it also integrates all of these features that are there, like debugger is integrated into that. And once you are done training and debugging and you deploy the model, then at inference time, production inference time, when drift happens, when anomaly happens, there is also similar kind of mechanism to detect that and alert. And as a result, you go back and retrain the model. So the whole end-to-end flow is all within the SageMaker Studio. Now, having said that, we are all engineers and developers. Not everyone likes to use IDEs and graphical user interface. So you have a whole set of API. You have Python SDKs, you have your CLI, you have API commands. You can use all of these features in any of the three ways: IDE, Python SDK, or API. So you have full flexibility around that. So I just wanted to clarify that. With that background, let's jump into the SageMaker Debugger part, which is what the focus is. But before I go into the debugging, I think it makes sense probably to spend a little bit of time talking about how machine learning training is done in SageMaker. So again, this is a very simplified view of Amazon SageMaker training. But if you look at it, there are broadly three different ways in which you can do training. The first one, which you can see on the leftmost side, is what we call as built-in algorithms, which are algorithms which SageMaker provides to you. And these are more or less like classical ML, with maybe XGBoost being on the arena. But there are a series of algorithms that comes with Amazon SageMaker, which you as a customer, you don't have to do anything in terms of making any changes in your training script. You just go in a SageMaker training container, you select the algorithm which you want to use, and you start off the training. Now, in this case, the start time, or the amount of time in which you start getting a model trained, is very quick because it doesn't require you to write your own script or build your own container or have those whole logistics that is required before you start your training. You already have the training containers, you have the algorithms there, you bring your data and you start. So that's what the leftmost is. The middle one is more for people who wants to do deep learning. So as you can see, all the popular deep learning models are there. We support TensorFlow, PyTorch, MXNet. We support also Keras, Horoword. There's a wide selection of machine learning frameworks that is already supported in Amazon SageMaker. Now, what does supported mean? So it basically means that we have taken each of these machine learning framework, we have optimized it to work on AWS infrastructure. So if there is any tuning that is required to use, for example, our networking, if there is any specific tuning that is required to optimize on S3. We have done all of that. And there are machine learning framework fork that we have done, and that is included and tuned within the container itself. So you as a customer, if you want to use any of this machine learning framework, you have an option to bring your training script, and within the training script, you basically write how your neural network model will look like. And the infrastructure of starting the training is all there for you. So you have a training container with the optimized version of, let's say you're using TensorFlow, the optimized version of TensorFlow is included. You bring your training script, and the work of instantiating the container, choosing the right instance is all done for you. You just say which instance you want to choose, you start your training. Now, when there is also customers who wants full flexibility, they say that, hey, you know what? I want to bring my own container. I want to build my own stuff because I'm not just doing training. I'm doing some pre-processing, I do training, and I'll do some post-processing. So as a result, there is more than training that they want to do within the container. So then in that case, we said, okay, fine. If you have specific requirement like that, you can bring your own container. So in this case, you do a little bit more heavy lifting because you have to create the container, you have to add all of that stuff, but that flexibility as well. So that's the 3 different ways in which you can use the training. Now, there are things that SageMaker platform takes care, like auto scaling. If you need more GPUs, it's already provisioned for you. So the infrastructure management and the heavy lifting and scaling is all done. So just to keep in mind, it's a fully managed platform. We support distributed training. It's auto scaled and it's secured. It's for production deployment, enterprise production deployment. Now, this is all good, but when you are doing training, what we are hearing from customers is that it's like a black box. How do I get more insight into my training? What happens? Let's say I'm using a multiple layer convolutional neural network. Let's say I have 10 layers, and I want to know each of these different layers, how are they behaving? That has been a challenging task. So let's talk about what challenges people have been facing and customers have been telling us. We all know that deep learning model training is not an easy task. It takes significant amount of time and effort. Usually, the neural networks have multiple layers. There are like more than 20, 30 layers that people are coming in and bringing in because of the sophistication that is required and the accuracy that they want to achieve. There are significant, it's more or less like your brain where neurons are being connected. So there are connections across these layers. And from one layer to the other layer, you are basically transferring information. And there is mathematical calculation being done at each of these nodes, if you will. It is extremely computational intensive because of the fact that you are doing thousands and thousands or even millions of matrix multiplications and calculations along the way. There is this concept of hyperparameters which you have to tune in order to get to the point where your model is acceptable and is giving you the accuracy that you care about. So essentially, if you start looking at training and a machine learning model, unless you know what is happening at each of these different layers, it's very difficult to tell what went wrong. Because you might go through the whole 2-3 hours of training and then figure out that, hey, it's not even converging. And it's so frustrating when you don't know what's going on. Like people who have done C, C++, and Java coding, GDP is like, it's just basic stuff. You just put a breakpoint, you go and look at what is going on there. We're so used to it, and that's how you debug your model. So now, in order to address that, people have been trying different things. These are all manual stuff that they do. Sorry about that. So in absence of a fully end-to-end tool which can help you find issues, what we have seen customers do, they manually print logs. It's like printf statements in your C, C++ program. They try to emit tensors manually. They try to emit scalars. And they are looking at it manually in order to figure out what is really going on each of these different layers. There are open source tools that they're using for charting, for visualization. Like, okay, let me look at my tensors. How are they looking like when I have gone through a few epochs of training. Then they are trying to figure out from that what really is going on during the training process. It is extremely time consuming. It's undifferentiated work, and it's a task that most people, if you have gone through it, you can probably relate to that. They're like, hey, I just don't want to do it. Can I have some other ways by which this heavy lifting is gone? So there has to be a better way, and there is. So we introduced, as of this week, a new feature called SageMaker Debugger. Now, what is SageMaker Debugger? As I was mentioning to you, we looked very closely at end-to-end flow of a machine learning training process. So first thing that we figured out is that there is not enough insight or information when the training is going on by which you can figure out what is going on. So to address that, we have a mechanism to capture data. It's automatically done for you. So when you start your training process, either through Python SDK or through API, the same training API that exists in Amazon SageMaker today has been extended to add capability to turn debugging on. And you can basically select what do you want to emit. So you are in control there. You can say, I want to emit weights, gradients, biases for a deep learning model. Or you can say, I want to create a collection of specific tensors. You can even give a regex and choose specific tensors you want to collect. And why do you want to do that? The reason is because in many cases, when you go through multiple epochs or multiple trials, you'll see that most of the common issues just get resolved in the initial 5-10 training trials. After that, it becomes more and more harder to find issues. It's just like C, C++, and Java programming debugging. It's the same thing. When you have runtime exceptions, it's very difficult to find because now you're looking at things changing at runtime. So to give the capability for emitting only what you care about, that's why the regex and collection comes in, where you say that, hey, I want to specifically get this set of tensors at this set of intervals. So you can specify interval as well. So as you can understand, right, if your interval is lower, there will be more data that will be collected. And if your interval is higher, let's say I'm collecting every 10,000 steps versus every step, then your data will be lower. So depending on where you are, what you are exactly doing, you're in control of what data and how much data to collect. Keep in mind that every data that is collected is going to go in your secured S3 bucket. We are not going to take any data and keep anywhere else where you are not in control. So even for most security sensitive applications, you can use debugger because we are not going to take any data out of your S3 bucket. You are in control. You can delete it. It's under your secure environment, just like any other SageMaker features. So I wanted to highlight that. Now, let's say the data is collected. What do you do with it? So when you start training, at that time, you also have an option to specify what we call as rules. Rules are nothing but, it's like assert statement. It's like Python scripts, which actually asserts for certain conditions or checks for certain conditions that you care about. With SageMaker Debugger, we have released a set of rules of issues that our customers have told us, and we have found out from our own experience that if you are doing deep learning training, then those are things that you will anyway hit. Things like gradients becoming too large or too small, losses not decreasing, for example. There are n number of conditions that you always face, and those are like very simple things which you want to get out of the way initial few training trial itself. So what happens is now with these rules being, so let me take a step back. So when you start the training process, you can specify a combination of these rules, so you can specify one or more. In addition to that, you can write your own rules, and you can specify that also. So when you specify rules, what happens? This is important. And I'm going to go into the details in the next slide. But essentially, we monitor for those assert conditions on your behalf when the training is going on at real time. From your standpoint, you did not change even a single line of code in order to use SageMaker Debugger because the instrumentation inside the machine learning framework is done for you. So you bring your script, you don't change anything on your script. When you start your Python SDK or you use the API, you specify, I want debugging, and here are the rules I want to fire. Okay, I'll give you an example in Notebook also. Now, SageMaker does the rest of figuring out and as soon as it finds issues, it will raise alerts for you. So now, instead of you going and manually analyzing it, the error comes to you. It's like an interrupt. So that's what we mean by automatic error detection. We know that you have written your neural network model. You are training with your own data. So you have much more knowledge about your particular machine learning model than us. So that's why we give the capability to you to write your own rules. So you can say, this is my assert condition, which I want the debugger to trigger when the training is going on. The other thing is that being a machine learning engineer or a data scientist, you want full control over the whole process. So you know exactly what tensors you have emitted because you have created a collection, let's say. So now if you want to manually analyze it, there's an option. We have provided an SDK. It's an API through which you can fetch each of these tensors and you can make your own plot and graph real time. So you start the training, and the training is going on. The matrices are emitted, and let's say the training is long. Let's say it's 4 or 5 hours training. Then what happens is, as the data is saved on your S3 bucket, our containers kicks off, and that's reading from there. And then the plots that you have done, let's say, in your notebook, you'll see graphs being populated automatically. So we have found very good feedback from our preview customers, where they found valuable insight, because now they have the ability to see and get insight real time into their training process. And I will show you some graphs later on. The debugger also supports distributed training. So if you have a GPU cluster and you have multiple instances running, we support that. And as I mentioned earlier, it's integrated with SageMaker Studio. I'll show you some of the screenshots later on. I briefly touched on how it works, but let's look at it closely. So there are three key things to keep in mind here. The first is data emission. So the data emission is when training goes on in the training container. We have instrumentation in the machine learning framework, which is part of the training container itself. So that is going to emit on your behalf. You don't have to change any code. If you're using script mode, you bring your own script, zero code change. If you're using built-in algorithms like XGBoost, zero code change. You just say that, here is my, I want to turn on debugging, and it just starts writing. Now, it writes to your S3 bucket. When you start the training, as I mentioned, you can have multiple rules, built-in and custom rules combined, or all built-in rules. As the training starts, we start off separate containers. For built-in rules, we manage. The debugger manages completely. So you don't have to specify instance. We select the right instance to run that. We instantiate the container. And once the training is over, we terminate that. And by the way, it's important to highlight, you as a customer do not pay anything, zero, for running built-in rules. So the built-in rule instance that is used to monitor is completely free. The volume that is associated with the built-in rule to collect the tensors, completely free. There is no charge for that. If you write your own custom rules, then you specify the instance that you're going to use, and you basically specify the volume that you'll use, and you'll be charged for the actual usage for that. So I wanted to highlight that. So once the training is going on and your rules are being monitored, let's say you hit a condition where one of those conditions is, let's say, vanishing gradient. And once this triggers, you will be alerted in few ways. There's a CloudWatch event that will come. And the CloudWatch event you can configure. There's an action that we already are adding called stop training. So if you know that there's a vanishing gradient that came up in the first few epoch, you don't want to continue the training. So you save money and you save time. More than money, it's time, because data scientist time is extremely valuable. So you iterate faster through the training process because you're finding issues ahead of time and the tool is alerting you. So the CloudWatch event, you can also say, hey, I don't want to stop the training, but I want to create a Lambda function to do something else, like deliver this through a different mechanism. You can do that as well. I already talked about the SageMaker notebook, where you're in control with the SDK that comes in to do manual analysis. Extremely powerful, because once you fetch the tensors and put a NumPy array, you are in full control. It's like you have the data right there, and you can slice and dice it in whatever way you like. And then finally, some of the charts that I'm going to talk about, I'll show you some of them that we have in Studio. but we will keep iterating it and make it better with your feedback. Let's quickly look at some of the screenshots. I know it's kind of difficult to read here, and I apologize for that, but I'll kind of highlight to you guys what this is trying to do. So this view is what we call Studio, SageMaker Studio. So the Amazon SageMaker Studio has this notebooks. So on your left, you have this notebook here. And it's showing you that here is how you start a TensorFlow training. All of the code on top is same, this identical as you are doing today. The rules part, which is the bottom part there, here we have specified 2 built-in rules and 1 custom rule. And this is where the Python SDK, this syntax is Python SDK. So we are calling loss not decreasing and poor weight initialization. These are 2 built-in rules that comes with SageMaker Debugger. And then just to illustrate, we are adding another custom rule called my custom rule, which is something that, let's say, a customer has written. So that's all. That's all the code change that you need to do. And this is basically not changing anything to allow SageMaker Debugger to emit, but it's basically saying what rules you want to use. Once you do that, you start your training, right? Now, if you switch to the right side, you'll see on top, we show a view of how this is running. So the 3 rules are now running. It says in progress, right? And as the rules are running, we are writing. Remember, we write data. So you can collect that, and we also show. So one of the things that we automatically emit is called losses, because loss is a fundamental thing that everyone finds valuable on how their loss is decreasing over time or not. So we plot that as well. So as you can see here, there's a plot which shows that over time it's decreasing, which is a good thing. It can remain flat. It can get worse as well, but you get a view of that. Remember, these are configurable views. This is not a fixed view. Each of these tabs, you can configure it and change it. We just set it up to show you. The next screen shows what happens when you do hit a condition. So rule gets hit. It says that in this particular case, vanishing gradient was found in your model. So on the right side, you see that we will alert you. It will say that the debugger found this issue called vanishing gradient. Here are some details of that. And you have artifacts that you can see as well. So this is a view of when you hit a particular rule. The next one is when you are running multiple trials, then you want to compare losses across different trials. So SageMaker Studio provides you an option to plot the losses, and you can select which trials you want to compare. So this is showing 2 different trials and how the loss is plotted against that. So why is it useful? Because if you're running multiple trials and you're doing experimentation, you want to know whether the change that you did in your hyperparameter, did it contribute to any kind of improvement or not. So a visual way of doing this is here. The other thing which I kind of briefly touched on earlier was the manual analysis. So this shows a custom analysis. The code on top shows how you are taking a particular trial. You are getting all the tensors. You're getting all the steps in the tensors. And then you're calculating a mean out of that. It's just a simple illustration of what you can do with a simple few lines of code because now you have the data. And then the bottom one is showing how you are plotting the different tensors in a graph. And this is using just matplotlib. You are free to use whatever library you like in order to get your own analysis done. And then the next slide is a custom analysis that was done in association with a customer. And here you can see the power of the manual analysis on the debugger part. In this case, what we are doing is we collected the tensors. We are plotting the gradient distribution in order to find out if there are gradients which are really small, which leads to vanishing gradient. And as a result, can you optimize your neural network in order to remove certain layers which may not be required? Because in this case, we did find that removing some layers were helpful. As a result, the model accuracy improved, the loss decreased, and the size of the model itself was reduced because of the manual analysis being done. Again, I'm not a data scientist, so I cannot go deep into this. But if you are a data scientist, you'll appreciate the kind of manual analysis that you can do by writing your own rules, custom rules. So that's a brief overview. we had the fortune of having a set of preview customers who worked with us and to try out and give us feedback. So today I'm glad to welcome JT from Change Healthcare, who used SageMaker Debugger with their deep learning model, and he's going to tell his experience about how his journey was. JT?
Thank you, Sanjala. Can you hear me, everyone? Can you hear me? Okay, perfect. So before I dive in, let me quickly introduce myself. Let's see. Okay. So my name is Jan Thomas. I'm Senior Director of Machine Learning Engineering at Change Healthcare. Change Healthcare is the largest healthcare network in the US. So we connect payers and providers, like hospitals, payers like insurance and providers like hospitals, and we process the claims. So we process almost 14 billion healthcare transactions and almost $1 trillion healthcare claims, dollars worth of healthcare claims. Our mission is to reduce waste in healthcare spending. To implement this strategy, so we are taking the huge amount of data in our network and using AI to do more accurate decision first, and then carry out these decisions by automation or routing to the appropriate skilled agent. So the whole idea is to reduce the rework loops. That's the main cause of this waste. You keep repeating the same thing, go back to the provider, and then send back the claim again with additional data. We want to reduce it with smart decisions and AI. So we have a wonderful collaboration with AWS. We've been using AWS as a platform of choice for our AI initiatives. Today I'm going to give you an overview of how we are using AWS in our AI development process, as well as sort of give an overview of our experience with SageMaker Debugger. What is our experience with SageMaker Debugger and our outcomes of that. So our typical model development process, so we use AI, Change Healthcare, we use AWS AI platform from end to end, like all the way from development all the way to deployment and production. So pretty much we consume all the AWS services. So let me dive into the model development process. Most of our models are custom models, which is essentially Dockerized. So we use SageMaker notebooks and custom script to develop models. These models range from classification models to NLP models, all the way to neural network model, CNN models, and other RNN models as well. So once the model is developed, we actually strip off the healthcare data in the model and then store it in the GitLab, which will eventually get deployed as Dockerized containers in Artifactory for further downstream process. So I'm going to dwell a little bit more into the training area, because that's the area of focus where we experienced SageMaker Debugger today. So our primary data source for training is our historic data is stored, and also the incremental data is stored in the data sources like Redshift as well as in S3. So those are the two sources. These data then gets cataloged in Glue, and then we have written our own custom extract and transformation script, which gets orchestrated using the workflow engine we have. And then essentially we use SageMaker for all our training purpose, where it's we do a lot of hyperparameters training. We do a lot of experimentation, many different iteration. So that's where our challenges starts. So we have to now manually instrument our models with manual code, and we had to manually analyze our all those output of that using different various open source tools. There is no standardization, and each of these iteration takes quite a bit of time. Usually, like one of our model, we spend 5 days training, and we had to wait till the end of it to analyze those data points. And it's also dependent on the skill of the data scientist. If the data scientist is highly skilled, is very efficient, but if it is not, he has to go through a steep learning curve in understanding all this debugging tools and other things. So it's pretty much a time-consuming process. We want to look at it and automate it. that's where I think our SageMaker Debugger really helps us in that area. So our deployment architecture I'm showing here is mostly all these models, once it is trained, it gets deployed for real-time inferences. So we have two different customers. One is our internal API, internal customers, and our external customers can also utilize these APIs by using the AWS marketplace. So these models actually are in the AWS marketplace. If you want to try it out, you can try it as well. And we use, to scale our model, we have our typical architecture, which is elastic load balancer as the front. And then we also have, for orchestration of different models and routing, or even ensembling the models, we have a gateway and a lambda function we used. And eventually it hits the SageMaker endpoints. We also collect a tremendous amount of metrics here. Using Kinesis stream, we log all the metrics, the model metrics, how the model is performing. All those things gets logged in for alerting as well as for further analysis. So we also have some QuickSight, which we do an analysis of the model outputs for further processing as well, understanding how it works. So in this case study, I'm going to go over, let's see how we utilized SageMaker Debugger in improving our model efficiency. So using a case study, I'm going to go through the overview. So this is our existing process. So where we receive a lot of these claim forms from our healthcare providers, they fax the claim, they send us images. Our goal is to automate this whole process as much as possible. So we have deployed a OCR and a custom workflow. This has been in production for last 10 years. So we process a lot of, almost like many different types of forms, as well as almost like 14 billion transactions goes through the system as well. So some of the challenges, okay. So we have many different challenges with this setup. So majority of the claims have to be processed by humans, which is almost 90% has to be processed by the humans. So as we already know, like manual processing is time consuming and it's error prone. The main reason for the low automation rate is the form, there is variation in the form, as well as there's counterfeit forms, and when they transmit the form, it's skewed and the resolution is low as well. So that's the main reason our automation rate is low here. So this is some of the examples of our claim forms which gets transmitted to us. So these are two different forms I've shown. It doesn't have any PHA data. This is sample data I've shown here for illustration. So our goal is to build a AI model which can do a pre-processing. So since this process has been in production for many, many years, and they have a lot of rules built in, we want to build up an AI model which can do pre-processing and utilize the existing process to make it highly efficient, like to improve the automation. That's our goal. So for that, we use SageMaker to build a model, which is a CNN model. What it does is it takes the distorted form and other form with low resolution, extracts the text, and then sort of cleans it up so that the OCR, downstream OCR, can process it efficiently. And with that model, we're able to increase the automation by 56%, which is a pretty good amount for us. And I have to thank SageMaker Debugger for helping us with this development journey as well. So let me a little bit illustrate what the model does. So it's a 10-layer CNN network. The first 5 layer does the downstream sampling. What it does is it removes all the unnecessary, extracts only the text from the forms. And then the next 5 layers, what it does is it upsamples. We take a template form and then overlay this text, and then such that it could be processed by the downstream OCR system effectively. So let me show you some example of what we have done. The original forms are in this format, and then what we've done is we've extracted out the text, and then the cleansed form is in the right-hand side here. So we pretty much use the SageMaker for building this model. Here's another example. The step one is what we do is we identify the form type. That could be, we support maybe 30 different form types. We identify the form types. and then we strip off the margins and and other details out and extract the text out, and then we take a template form and then overlay, place this text in the right places such that the OCR system can extract the data out. So our goal is to improve the accuracy of the model such that more and more forms can be automated, and also gain additional insight into the 10-layer network, what activation function we need to use, and do we need to remove any layers, things like that, or change the hyperparameters. So that's where we utilize SageMaker Debugger to sort of improve the accuracy of the model. So I'm going to explain you in the next few slides how we're able to seamlessly progress from development into debugging with SageMaker Debugger. So this is our improved model training with SageMaker Debugger. This model takes at least half an hour to train. So what we have done is it actually has a training set of 300K images, which is many of these things are synthetic images we created ourselves. And then it's a TensorFlow model. So what the two features we used is the tensor visualization. We configure the model to emit all the tensors so that we can do analysis on the distribution of the tensors and weights and other things. The other one we also used is early stops. We used rules to stop the training so that we can do multiple experimentation to improve the model performance. So no code is needed. No code changes were done. From our side, all we did is we just configured some rules external to the model, and voila, we got all this nice new features of the debugger, so that we can do custom analysis as well as we can do early termination of this model as well. So here is an example of what the configuration of the rules. You can see here we configured it to emit the weights as well as the loss functions as well as the tensors. So in this section, so we did custom analysis of the tensors. The tensors, all of the tensors gets deposited in S3, and then we can do custom analysis using distribution and other analysis the data scientists can do to improve the performance of the model. So the outcome of this experimentation is we're able to improve the performance of the model by 56%, and it helps the SageMaker Debugger helps increase the accuracy of the model as well as helps us understand the model better. What layer worked well? We can have a clear, historic, by analyzing the tensor, we clearly know what's happening in each of the layers. And also we're able to, gain deeper insights into the model by analyzing the tensors. And we did utilize the early stops to stop the training as well. Those are the features we use. So our future plan is to use debugger as a standard across all the 40 different models we have, and develop standard hooks within Change Healthcare and add custom stops to detect specific models. So our experience has been really wonderful, and thanks for the partnership with AWS.
All right. Thanks, Jerry.
Thank you.
So I'd like to encourage you guys to check out the sample notebooks which are already live under AWS SageMaker examples. There's a new folder called SageMaker Debugger now. So there's a bunch of sample notebook. You guys can start going through it. So in addition to that, there are some of the other sessions that are there between today, tomorrow, and day after. Feel free to stop by to learn more about the studio, the model monitoring, which is when you deploy the trained model and you're looking at drift and anomaly detection and so on. We have autopilot feature which we announced, which is AutoML, all within SageMaker, where you point to data in a tabular format. The model building, training is done for you. So feel free to check that out as well. And then there are other sessions where we announced how you can use SageMaker features within your own Kubernetes environment using Kubernetes operators. So we announced a new feature called Amazon SageMaker operator for Kubernetes. So feel free to check that out as well. With that, we conclude the session. Thank you so much for your time. Both JT and I will be on the site to answer any questions that you guys have. So with that, thank you and enjoy the rest of the conference.